Now we're going to look at surface area of a prism. We looked at nets, how the nets form the shapes of 3D objects. Now we're going to look at taking all of those faces of the object and finding all the areas of each face and then adding all those together. So recall what a rectangular prism net looks like. This is from the previous lesson. And we can notice now that I put on dimensions here. There's the length along the bottom, there's the width along the side, and the height to the top. And this actually shows how I find the area of each one of these. So I have length times height would be this piece here. Length times the width would be the bottom and the top. And then the width times the height, which is over here, would be the two sides, the right and left side. So you need to find the areas of all sides and add them together. That's basically what we're going to look at doing for all of these shapes. Also include proper units. For area, we use the squared symbol. For example, we have centimeters squared, inches squared, feet squared. So for area, that exponent of 2, or squared, has to be included to show that the units are area units, not just length, width, or height units. And it changes again when we go to volume. So we use a little 2 to show that it's units of area. Okay, so let's look at this example here. I have a length, if I'm looking at this type of thing, a length of 8. I have a width of 4 and a height of 3. So when we're finding the area of all the faces, you have to make sure that you're finding each and every face. So I'm going to do the front and the back, then the sides, both the right and the left side, and then the top and the bottom. So remember, with like square prisms, rectangular prisms, they have 6 sides. So we must be finding all the area of all 6 sides. So for the front, that's this face here, right? Which would actually correspond to this part right here, the blue. And that's going to be 8 times 3. Okay? Which is 24. And we have to multiply by 2 because we also have the back as well. So the front and the back is going to be a distance of 48, and the units on this is inches squared. The sides, that's these right and left hand sides, which are like the width times the height, these pieces here that fold out. So that would be, if you can look at it, the bottom side here is the same as the bottom side over here. So we have 4 times 3, or 3 times 4. Which is 12. Again, I'm multiplying that by 2 because we have a right and a left side. So that is 24 inches squared, or square inches. You can say the same thing. Both of them mean the same thing. And then the top and the bottom. So the top and the bottom are like these pink parts here, up here, the top and the bottom. And they are the 8 times the 4, because that's that bottom rectangular piece. We have 8 times the 4. And that, of course, is 32. Again, we multiply by 2 because we have the top and the bottom. If I just included 32, that would just be the top or just the bottom. So I multiply that by 2, I get 64 inches squared. And I add all these together. So don't be opposed to using your calculator. It's totally fine. You can use a calculator for this course. So 48 plus 24 plus 64. I know you could add up the right-hand side, but because these questions in grade 8 get a lot bigger than just adding and subtracting, we're assuming that you know how to add and subtract at this point, so don't worry about using a calculator. So I get a final answer of 136. So 136 square inches, or inches squared. Okay, so hopefully that one makes sense for the rectangular prism. The formula, if you want to look at a formula for this, I'm not big on formulas, but you do tend to use them in higher grades. But for now, it's nicer just to look at finding the areas of all the faces and adding them together. But if you were to look at a formula, we would look at something like this. You'd have 2 times, and you'd have, what did we do? We did the front and the back, which was that length times the width. Or no, the height times the length, or length times height, plus we did the sides, which are the right and left sides. That was the height times the width, or width times height, plus, and then we did the top and the bottom, which were the length times the width. Okay, so if we add these all together, and then take that total and multiply the total by 2, it would be the same as taking each one times by 2 and adding them, what we did up here. what we did up here is we took one face, multiplied it by 2, one face, and so on, and then added all those together. We didn't multiply the total by 2. But this one, this formula multiplies the total after we add them all up times 2. So we don't multiply the sides by 2. That's why I like this way better. It makes more sense. However, formulas can work as well. Okay, now I'm going to look at a triangular prism. So this example is kind of done for you. I'll give you maybe, you can pause the video and maybe jot this down. Drawing triangular prisms is kind of hard. I'm not great at it. So you would start off with like your triangular face, and you would extend it out and have the same type of, everything has to be the same angle, right? So this top has to be parallel to the bottom, and that side has to be parallel to that as well. So in this case, again, we add up all the sides together. Okay, so we have the front, check, the back, the bottom, the left side, and the right side. These ones are a little more complicated to see where all these pieces are. So I have the front and back, which are here, of course, and at the back, which would be the same shape. They're both that triangle of 4 times 3. But remember that a triangle, over here I've drawn it, 4 times 3, I also have to divide by 2. And the area of a triangle is base times height divided by 2. In this case, the height is 4. So I have 3 times 4, and then I'm going to divide that by 2. 4 is the height. That's the height of this triangle. Some triangles will be drawn like this, and they'll have, as we'll see in the next example, they'll have a dotted line. That will show you, that dotted line will show you what the height is. But for this triangle, because it's drawn like a right triangle already, the height is just the left-hand side, or whatever side it happens to be of the triangle, because it's a right angle triangle. So we took 3 times 4, which would be 12. Divide that by 2, which is going to be 6, which I have there. So the front is 6, because base times height divided by 2. They're both triangles. The back is also 6, because it's exactly the same shape. The bottom side, if you can see, is going to be like a rectangular shape. It's going to have this side 3, and this side 9. So you'd have like that side 3, and then that side 9. You'd have this like bottom rectangular shape. It would be an actual rectangle. It wouldn't be slanted like this. I'm drawing it like this because I'm showing you what the perspective would be. But it's a rectangle with a width of 3 and a length of 9. So 3 times 9 is the area of that one. And these are all in centimeters. Left side would be the side over on this side. And you can see that it would be a rectangle with a side of 4 and then a length of 9, right? Because that 9 is the same as the length over here. Those are both the same length. So it would be, again, like this type of thing. You'd have that extending all the way, and you'd have 4 and 9. So 4 times 9 is, of course, 36. Let's get rid of some of these arrows. So that is the left-hand side. Now, the right-hand side is the one that's, in this case, it's easier. It's shown to you right here. It's going to be a length of 5, or a width of 5 and a length of 9. So I add all those pieces together, and I end up with 120 centimeters squared. Okay, so we have the front, the back, the bottom, the left side, and the right side. This is for a triangle, right? So you only have around the edges, or around like the, I don't know what you want to call this, the sides of the triangle, you only have 3. You'll have a left, bottom, and right. Okay, because that's how the triangle works. So let's look at one more example here. So this time, like I showed before, the triangle is drawn a little bit differently. It's not a right angle triangle. It might be an isosceles yeah, it is an isosceles triangle because I have a 7 and a 7, which will be the same as this. So these two sides here are the same length. So it's an isosceles triangle. So for the front, again, I have the base times the height divided by 2. The base is 4. The height, like I said, is that dotted line, which is going to be 6 divided by 2. 4 times 6 is 24. 24 divided by 2 is 12 centimeters squared. The back is exactly the same shape, so that one's nice. It's kind of given to you. So you know it's going to be 12 centimeters squared again. This one's drawn a little nicer because we can actually see that the bottom is a rectangle. We can see all the dimensions of it. There's 4 and 12. So the bottom is 4 times 12, which is 48 centimeters squared. The left-hand side is the side over here. And hopefully you can kind of see, okay, the top part of the rectangle and this slanted part. Okay, so it's that whole the top part is the same as this bottom, so that's 12 all the way across. And this slanted part is shown to us over here, same as that side. It's kind of hard, you got to fit some pieces in. So that's going to be 7. So we have 12 times 7, which is 84 centimeters squared. And then the right hand, in this case, the right side is the same. It's just 12 times 7 because this is an isosceles triangle. Doesn't always work out that way, but this time it did. 84 centimeters squared. And again, we add all those pieces together. So we have 12 plus 12 plus 48 plus 84 and another 84. So we end up with 240 centimeters squared for the total surface area, SA, surface area, of this triangular prism. Okay, so in conclusion, the easiest way to do these, again, we don't really need a formula for these. There's no formula. It's just surface area. Surface area of a three-dimensional object is finding the area of every single face of that object and adding it together. So I hope that helps. You can rewatch the video if you need any more help, or let me know.